Yeah, cool. All right. So, Unit 3, water distribution. Expanding watersheds. This is, like I said, from Chapter 3 in our Carl book, The California Water Story, basically, page 89 to 115. Okay? So, expanding our watersheds, the first thing we need to know in this whole discussion is that it's a virtual water story. In other words, what we've got with our water really is man-made, okay? And so we've created what they call virtual watersheds. Means that we move water around so much that what water comes to a certain area, right? A certain watershed, highest mountain range to highest mountain range, generally doesn't really describe what's going on in that watershed because most of the water for that is actually coming from outside. That's not true all over the state. If you go to Northern California, you go to Santa Rosa, for example, wine country, their watershed is their watershed. They don't have any artificial aqueducts coming in to augment, or they don't have too many dams and all of that. So that's where we are. It's artificial, it's man-made. It's the biggest one in the world by a mile. We have some big ones in South Africa where I grew up, and they've kind of fallen into disrepair. And you might have heard that Cape Town, the southernmost city in Africa now, South Africa, is in a terrible water shortage. And part of the reason for that is that they don't have this kind of virtual water supply, this man-made water supply to help them out. They tried to do that, but in the recent years, with the political disruptions, that's kind of broken down. Without that, guys, if we don't have this man-made system, we'd be looking at Cape Town right now. We'd be in exactly the same situation. We do not, just looking in this area, Mojave, about 400,000 people, we not even close have enough water to supply those people. LA, it's ridiculous. They don't even have close to the amount of water they would need to supply their own water from their own watershed. The runoff coming from the mountains, going into the groundwater, and then them drawing it up, right? So that's not even, it's not even close. So we're very dependent on this artificial water supply, and that's what we're going to talk about in most of this class, is how do we manage that, okay? We talked about how 75% of the people and demand for the water in California is in the south, right? So we're really talking from San Francisco, below San Francisco down, okay? And it's a semi-desert. I was just looking, interestingly enough, I was looking at San Bernardino the other day, and there was a figure that I saw that the average rainfall in San Bernardino is about 5 inches. Well, traditionally up here, long term, we've talked about average up here being about 8 inches, 5 to 8 inches. So we might actually get more rainfall than right downtown San Bernardino. And you don't think of that. When you look at all that development out there, all of that, it's pretty amazing. They literally live in a desert just as we do, okay? And it's distributed intricate network of canals, but dams and pumping systems. So if you see map 12 in your book, that'll kind of give you an idea. And then real quickly, back to this old story. Hopefully we'll get beyond this pretty quickly, but the text says that 80% of the water is used for agriculture. Okay, so what does that actually mean? Anybody want to take a shot at that? Why is it that they say it's 80% used for agriculture, and we say, and the Department of Water Resources says that it's 41%? Anyone want to take a quick run at that? What's the reason for that? I'll pick on Enrique. Why is that, Enrique? He's hiding. I can't even see him over there. Where is he?
I'm over here.
Oh, yeah. What's the reason for that?
You say why is there 41% agricultural usage compared to 80%?
Yeah.
What did you say again? What was the question?
Yeah, the book, our text, Carl book, the little blue book, says it's 80%. Everyone else, most other people, a lot of other people say it's 41%. What's the discrepancy?
I would say it's because there's a discrepancy between our local water supply and the water supply that we're importing from other areas.
Yeah, not exactly in this case. It's right there, actually. It says excludes 39% for environmental use. Old school, we didn't even, it's so new that we would look at the environment as a legitimate user of water. We didn't include that. So if you just take water supply that comes to people for agriculture, for urban, for industry, then it's 80% of that is for agriculture, okay? But if you start the math off different and you say, okay, let's look at the three major users, urban or people, agriculture, and environment. So if you factor in the environment, which is 39%, then that percentage drops to 41%. So it's still the biggest user of water, just a little bit more than the environment. So the figures that we're using and are actually more accurate, much more accurate, are 41% for agriculture, 39% for environment, and 20% for urban. Why is that significant that we look at that? Well, the numbers are never that significant, but if we're going to manage something, you've kind of got to know who the big users are. You've got to know if you hear an issue that's in the urban area, right, in the urban thing. So, for example, a couple of years ago, the governor came out with a mandate to reduce water use by 25%. Well, that sounded great if you were looking from the outside because you're like, oh, 25%, that's amazing. Well, it was only 25% of the 20%. The 20% that's for urban. So that's even if we achieved that, which most people say we did, unfortunately we've since forgotten about it and thought we've got unlimited water supplies again, and that people's thinking has kind of drifted away from that, and lots of jurisdictions are not enforcing that 25% reduction again right now, even 2 years later. But it's only 25% of 20%, rather than 25% of 100%, the whole, okay? So it makes a big difference as to maybe to look at what the users are in the first place, okay? So expanding our watersheds, again, how do we do it with the artificial use of water? Another way we're going to find out we expand our watershed even beyond California is we basically steal water. People in other states will say, you guys are taking our water, and how do we do that? That's from the Colorado River, right? Huge percentage of our water for Southern California comes from the Colorado River. Where does that watershed? That watershed's all the way up to the Rocky Mountains, right? Very little of that water, almost none of it, is actually landing in California. Because by the time the Colorado River hits California, it's extremely dry. Not the river, but the surrounding area. So they're not going to get any runoff, any water from underground out in those areas. That's significant, okay? And the whole point about this, what we need and what we're allocated is 5 times greater. So what we need and what are allocated. So there's this huge discrepancy of everyone saying, okay, well, we'll allocate this water. So locally, big story lately was with the big project. Help me out, Mr. Hafan. Big project in Hesperia. Huge housing project. The Tapestry project. Almost another city of... Sorry, Mr. Hafan?
Las Flores Ranch.
Yeah, it's on the site of Las Flores Ranch. So it's over towards Silverwood, all those hills from us here at the college, all over towards the south. There's a massive project over there that's almost the size of Hesperia, 120,000 houses, something like that. And they're fighting right now, and lawsuits are flying around because the city of Hesperia said, oh, no problem. We're just going to allocate you that water that you need, okay? State law right now just says that the agency that's supplying the water only has to prove that they can have it for 20 years, a 20-year supply. So we'll allocate you the water. Well, the problem is that water has already been allocated 5 times before when you look at the big picture of California's supply. And that's because everywhere, a whole bunch of people have different jurisdictions. This all changes, you guys, now with the new groundwater law. probably people think the largest, most important piece of legislation in California's history, because each watershed, each groundwater basin actually now has to be sustainable. So if we, as the Mojave watershed, say to Hesperia, we can allocate you that water for that housing development, we've got to deliver. And if we don't deliver, the fines will be massive. So my little personal take on whether the Tapestry project will happen or not, I personally think not, because of the groundwater, the Sustainable Groundwater Act, which is SGMA. Okay, that's the acronym for it. The SGMA will prevent that, because we can't just, Hesperia allocates water, Mojave Water Agency allocates water, Atalanta allocates water. No, we all have to come together as one groundwater basin and decide on that. We don't just get to over-allocate it, right? Okay. 80% used by agriculture, question mark, we're over that. 6 major systems in California, we're going to cover 4. There they are, basically, if you look at them real quick, kind of an awful slide, I apologize. Hetchy and Mokelumne, which goes to San Francisco, Central Valley State Water Project. So the State Water Project, this is a pretty decent map, you guys. The red coming down here all into us, right? That's the State Water Project, this red line. Starting at the Sacramento Delta, we'll talk about that in a moment. Actually, the water is pulled from way up there, but it comes down the Sacramento River, and then at the not the Edmonston, but the other pumping plant, they pump it out of the Delta there and into the State Water Project to come to us. Little channels go off at Santa Barbara, at San Luis Obispo, and at Santa Barbara, okay? And then the Central Valley Project is the next one, which is in yellow. And then finally, the Colorado River Project, right? 2 aqueducts, main ones, American on the very south, and the Colorado River Aqueduct. You can just see a little part of it right here, okay? But these are the major water systems in California. As you can see, and then there's all kinds, those are just the big aqueducts. It doesn't even show the dams and all the little minor aqueducts, okay? State Water Project, how did it happen? California's population doubled between 1940 and 1960. So planners started to see, hey, we've got to get more water to California. So now we're starting to talk about the State Water Project, the one that ultimately ends up coming through Hesperia and ending in Silverwood. The last water above ground or flowing in an aqueduct above ground is Silverwood. From there, we'll see in a moment, it goes underground down to Lake Paris and all over the LA basin, right? Okay. You can see some of those pipes if you look at Cal State San Bernardino. If you guys have ever really looked, you look up against the hill. Any of you played club soccer? Those big the soccer fields that are right there next to Cal State San Bernardino. You look up to the left and you see these massive pipes coming out of the San Bernardino Mountains right there at Cal State. That's part of the State Water Project, but it officially ends at Silverwood, right? Okay, so they recognized the problem. They saw that we could pull water from north, and in those days they were able to do it. These days, most people don't believe that they would have been able to take that water from the north. They would have stopped us from doing that. So, and it was used also for flood control up in the Feather River Valley around some of the lakes and stuff up there. And also another reason that it was put in place was to prevent salinization of farmland. Okay, so AAE, you guys did environmental science last semester. Granite Hills did sustainable agriculture. So somebody on Granite Hills side, what is salinization of agricultural land? What does that mean? What is that? How's it go? Anyone?
Oh, it's salt content. like the salt content in the soils and like the dirt.
Oh, that's perfect. Is that one of the famous twins?
Yeah.
Oh, well done.
Yeah.
All right. So you put your heads together and you got that great answer. That's good. All right. Yes, exactly that. When we irrigate, which most crops in the San Joaquin Valley, pretty much all of them are irrigated. They don't depend on natural rainfall, which we call dryland farming. They depend on being irrigated from this water system. When you do that in a very hot climate, the salts get left behind. And most of those salts just purely are actual table salt, right? And other salts like calcium salts. And it salinizes, makes the soil salty. And you can reach a point where it becomes too salty for certain crops to grow, okay? So the State Water Project was intended to help with that problem. Didn't do much because it was supposed to actually have enough water to kind of flush the soils, but that hasn't really happened. But that was one of the ideas. That's a whole nother story. But one of the ideas why they initiated the State Water Project was to help with salinization. Flood control, but mostly the top reason is so many people in Southern California. Okay? Plan established in 1957, $1.57 billion bonds, and the California Aqueduct, and all of that was built, right? To this day, if you guys own homes or your parents own homes in the area, we still pay some of those bonds. If you ask your parents to look at their real estate taxes right now, today, they're kind of coming up right now, the next payment of taxes for your homes, you'll see that there's Mojave Water Agency, MWA 1 and MWA 2. And you guys, we pay the interest on those loans. A bond, these kind of public bonds are really a loan from the government, okay? And we, as the citizens, to this day, if we live here, we pay back that interest on those bonds, okay? And that's levied as a tax on your real estate taxes, okay? So, and, you know, we get good use out of it. We've got a very balanced water supply here in the Mojave Desert. We probably won't have to move to somewhere wetter very soon because there's a good chance we can manage it, manage our water supply. And it's because of the State Water Project. That's what allows us, we'll see with the adjudication as we talk about Mojave Water Storage, that's what allows us to take water out of the aqueduct and pump it over into the river and recharge our groundwater and recharge in other areas like over near the freeway. Okay? State water providers cannot actually deliver the safe yield. Okay? So each area, like for the whole of California, there's a safe yield. So we look at the State Water Project and we say, okay, we think they planned it that it could deliver 4.17 million acre feet, okay? But that's calculated in a good year. What's happened now with prolonged droughts is that we can't always deliver that amount of water to us, to LA, to Santa Barbara, to San Luis Obispo. We can only traditionally do 55% of that. So when they do their calculations, Mojave Water Agency does their calculations for this area, they factor that in. They don't say we can get 100% of our allocation from the State Water Project. They calculate on much less than that. And I think they use even less than 55%. Okay, a couple years ago, we only got delivered, in 1 year, we only got 5% of the allocation. So because it was so dry. Then last year, we were back up, I think we got back up close to 100 because of the big floods and lots of water. And I was just on the drive in today, I was hearing that if we get 2 more decent snowfalls in the Sierras, they're coming pretty late. Mammoth got hammered with snow a little while ago, for example, a couple of days ago. Then we could come up to a normal snowpack, okay? This is the most critical thing for us in California, right? 55% of our water bank, our storage, comes from these mountains, okay? It was kind of like to me, it's kind of a miracle. I mean, you've got this snowpack, you've got this mountains that can store water that runs off just when we need it, in the spring, in the summer, when we are starting to use more water to grow crops and it's hotter and irrigate our landscapes. Now, all of a sudden, we get this runoff. We're able to trap it in dam and ship it to where it's needed, okay? Take Santa Barbara, for example. A few years ago, I'm going to say 15 years ago, Santa Barbara had a terrible drought, and they ran into a big problem with just having enough water in general, because they have a tiny little watershed. If you guys have been to Santa Barbara, drive along the coast, and you probably noticed this when they had those big fires a little while ago, and you look up and the mountains go straight up from there. So that's great and it's pretty, but that means that they only get runoff from that little bit of mountains. There's not a whole big valleys and watersheds to collect water for Santa Barbara. And so they're very, very dependent on the state water project. Okay? So because we've got allocation and then actually water that's delivered, that they deliver to us because of the droughts, there's a thing called paper water. So there's a lot of water rights and things that people have that are actually only on paper. Okay, and that becomes very complicated when we're trying to think about the Tapestry project. Are we going to be able to supply the Tapestry project? Should we as a local people approve that? Well, if so much of it is paper water, kind of immediately makes the case in my mind, well, it probably isn't a viable project. Okay? It's viewed as a legal entitlement and drives bad government planning policies. Okay? Nothing against Hesperia, all cities do it, but pushing the Tapestry project, in my opinion, and this is only my opinion, is right now is bad planning. Okay, there it comes. You've probably seen this picture. Matt had this picture the other day. There's going to be some crossover here a little bit. This is what it features: 28 dams, 29 dams, 18 pumping plants, 5 hydroelectric power plants. Remember that these projects also have a secondary benefit of producing electricity. That's kind of quite significant, actually. And 600 miles of canals and pipelines. That's only the state water project, right? And that includes the 444-mile-long California aqueduct, which if you go over to the end of Hesperia there, they used to allow you to go over to it. It was really cool. If you go south of Hesperia and drive up on those little hills there, there's this place, and you used to walk right up to it, and there was just a little fence around it, and there's this incredible waterfall where that water just goes straight into the ground, shoots across Summit Valley, and comes up in Silverwood. And if you go to Silverwood and you're going along and you see the dam when you get into Summit Valley, you look on the left, you'll see all these buildings. That's actually a hydroelectric plant from that siphon. That water is actually siphoning down and over into Silverwood. And they're actually water's driving those turbines when it's going up because of the pressure coming down and across. Now, when we go next week, by the way, Mr. Huffine and Mrs. Pike, are we okay with the field trip forms? You guys? Yeah. Hey, we're everybody's on the same team, yeah, right? We're the same team. Got to have them by tomorrow. Not tomorrow, but Thursday. Please, okay? Otherwise, I get in big trouble. I literally have to go to the VP today and tell him, hey, we're doing this all late, mostly because it's Neville's fault, which it is, and mostly because you guys have had to register late. But we've got to get them by the end of this week. I've got to be able to turn those in Friday morning, okay? But anyway, when we do that field trip, we're going to go to the Mojave Water Agency Operations Center, top of Deep Creek. And one of the plans that we wrote a letter for recently from the Resource Conservation District is they want to put a hydroelectric plant there. Because when they pull water off the aqueduct up on the hills to the west of that, it builds up tremendous pressure as it comes down to the Mojave River. Part of that water sometimes goes out in the river and recharges the groundwater. The rest of it goes over to Yucca Valley, okay? And that's the part that Matt Howard's going to be talking about tomorrow, is How is our water managed here? Yucca Valley, over 25 years ago, started running out of water, and so there's an underground pipeline that goes all the way to Yucca Valley, all across the front of the Marianas here. Okay? Major dams are Oroville Dam on the Feather River. That's the one that almost broke last year. The San Luis Rey Reservoir, which is further south. Then they store a huge amount of water. Okay, those are big dams, very important. Oroville Dam, we've already talked about, really critical. It almost burst last year. I hope that they fixed it in the last year because it looks like they're going to get a decent amount of runoff again this year. Okay, the Harvey Banks Delta pumping plant pumps water into the California Aqueduct at the Delta. Okay, so look at the map. You'll see that the Feather River, right up here, is way north, all the way up to Lake Shasta, almost at the very north of California. Water from that is